Okay, today's section of 3.6 is going to be based on the fundamental theorem of algebra. The fundamental theorem of algebra. Okay, and we have talked about this in a previous class. Okay, so we're going to find all zeros of the polynomial function, including multiplicities, real zeros, and complex zeros, which complex is imaginary. So if a zero has a multiplicity, what does that mean? If there's a multiplicity. Yep, if there's an even one. And what does that even mean, right? If it's a multiplicity and you see that on the graph, there's more than one, right? So sometimes there's two. We're going to find out today. Sometimes the multiplicity can be 3 or more. So the zero occurs more than once. Okay, so some of you already told me what we're going to look at here. So how can you tell from the graph whether or not a polynomial contains a zero with a multiplicity? So we talked about how you could have that max or min on the x-axis. Okay, this means there's an even multiplicity. Okay, there's an even multiplicity if it touches the x-axis and it does not go through. Okay, so an even multiplicity could be a multiplicity of 2, 4, 6, 8, so on and so forth. We're not going to be working with polynomials that are that big, so the most you'll ever see would likely be 4. Okay, and this is where it touches the x-axis, but it does not go through it. Okay, it does not cross it. Okay, and then if you have an odd multiplicity, okay, that would be a multiplicity of 3 or 5.
But at this time, please release your cross-country athletes. Thank you.
Do any of you remember what the graph does if the multiplicity is odd? Do you guys remember what word we used to describe it? Yeah, yep, it bends through the axis. Okay, so there's going to be some kind of bend as it crosses. Okay, so look something like this, and then it bends as it crosses the axis. Okay, so this is going to be helpful because we're going to be doing synthetic division again today. Okay, what we're doing today is going to be very similar to what we did in 3.4, but we're going to be extending this to imaginary zeros. Okay, so when you have a multiplicity, that means a zero is going to occur more than once, and so you'll know to check those values. Okay, so if you are finding all the zeros of the polynomial, based on what we did in 3.4, I know many of you could do this whole problem without me, okay, but it did seem on the last quiz I had a few people getting stuck on the one where you had to find the zeros. So we're going to just review some of those strategies. And we are finding all of the zeros. Okay, whenever you are finding all of the zeros, you have to use exact values. Okay, I still We've had some people on the test not find your exact values. Okay, you are not just using the zero function. Okay, you're going to have to use the quadratic formula. So let's start by identifying how many zeros you need for this. Okay, can you guys tell me? Yeah, why? It's the degree. Okay, so you need to find 4 zeros. Why? The degree is equal to 4. Okay, and just a reminder, degree is the highest exponent. Okay, so whatever the highest exponent is, okay, whatever the degree is, that is going to be the number of zeros you have to find. And that, my friends, is the fundamental theorem of algebra. Okay, so the fundamental theorem of algebra tells us, okay, that the number of zeros is equal to the degree. That includes multiplicities, that includes imaginary zeros, okay, that includes real zeros. So when you are finding the x-intercepts, these are the real zeros. Okay, you can see them. So I want you guys to graph this on your graphing calculator, just like we did in 3-4. And you can even start on step 2. Okay, and then once you find your intercept, do what you need to do next. Okay, and then once you're looking at the graph, you can verify it with your table. Okay, I can see that 5 is for sure a 0. Okay, and then I can see there's another one on the graph. Okay, what we can do is we can do synthetic division, and we can see if we need another 0. So I have 2, -7, -4, -50, -25. Again, I want to encourage you to use the space you need to succeed, because if we scrunch some numbers together, right, sometimes we read them as one number, so we want to avoid that. Okay, we'll multiply, we'll add, and if we did it correct, we should get a 0 as the remainder. Okay, now I know this isn't factorable, 2, 3, 11, 5, they're all prime, so I'm not going to be able to break it down. So what I want to do is see what this 0 is, and I want to see if it's rational. If it is a rational 0, I should be able to use this possible rational roots theorem that we discussed earlier in this chapter. So I can do the factors of the constant, so the factors of 25, over the factors of the leading coefficient, which is 2. And I know that all of my possible rational zeros come from dividing these. So it's the positive and negative of 1, 5, 25. When I divide by 2, I get 1/2, 5 halves, okay, and 25 halves. So these are what all of my possible rational x-intercepts should be. Based on this list and based on this graph, okay, look and see where the position is of the next one. It's between 0 and -1. Which one of these on the list is between 0 and -1? -1/2, right? You could also use your 0 function, okay, to verify. So it's asking me what's the left bound. I want to get as close to that as possible. I could go to the left, go to the right, make my guess, and see that it's -1/2. But you don't have to do that. You can also use this as a tool, and you know it's a 0 if you get the remainder of 0. So I'm going to check it with synthetic division. So -1/2 times 2 is -1. 2 times 1/2, which is going to be -1 again. 10 times -1/2 is -5. Okay, so that is a 0 as well. When you do synthetic division here, you have a number, an x squared, and x cubed. So this is a cubic function. Okay, this is a quadratic function. You know that you are done with synthetic division when you have a quadratic equation, because you can always solve that with the quadratic formula. Right? When you have a quadratic equation, you are done with synthetic division. Now, in rare cases, you could do what? In rare cases, it would be when you can factor the polynomial. We have discussed some of those cases. We will continue to discuss those. Okay, so if the polynomial is factorable, you could stop earlier than the quadratic. Okay, but you always want to get to the quadratic because you know that equation is going to work to find your zeros. Okay, so we have 2x squared plus 2x plus 10. You can do the quadratic equation from here. I also encourage you to look for a GCF, because if there's a common factor that goes into everything, we can divide by 2. You don't have to. Okay, so either way, you're going to be solving an equation using a quadratic. Okay, so I'm going to give you a moment to try that now. Okay, just try the quadratic. Okay, and then when you simplify, if you just want to put above what you're subtracting, so you don't have to write it out another time, that is fine. And then if you have a negative under the radical, we just have to remember you will have an I, which you can either write in front of the radical, which you'll commonly see, or you can put it on the side. Okay, and then when you are writing out your zeros, keep in mind the number should match the degree. So we need 4 zeros. So we found 5 and -1/2 doing synthetic division. The other 2 are here with the plus or minus. Okay, and that's going to be your final answer. 5, -1/2, and -1/2 plus or minus I root 19 over 2. Okay, so for part B, we're going to do something similar. So I'm going to have you start by graphing a polynomial and finding the x-intercepts. So we have x to the fifth minus 2x to the fourth plus 2x cubed minus 4x squared plus x minus 2. Okay, so your first step is always going to be to find an x-intercept or x-intercepts. Okay, so let's plug that into our graphing calculator. And then based on what you find, I want you to do the synthetic division, okay? If you can go further, go further. All right, we're getting stuck somewhere, some of you are looking at me. So what's up? What's happening on the graph? Well, what do we find? Okay, so you have a 0. What 0 did you write down as your x-intercept? 2. Okay, and then did we do synthetic division? So 1, negative 2, 2, negative 4, 1, negative 2. And then you had a lot of zeros that happen, right? Just make sure when you're doing this, you're double checking things as you go. Okay, now if this was on the x-axis, I would have a multiplicity. Okay, the maximum, but it's not on the x-axis, so I don't have a multiplicity here. This is going straight through. Okay, so I don't have a multiplicity. I don't even have another real 0. So what do you think we're going to have to try? What do you think? All right, I'll walk around and see what you guys try. You guys can talk with your table partner about it. And we'll write a note down. From the graph, there's no indication of another real 0. It could be out of the frame. If it was out of the frame, I could scroll my table. I could look for anything there. There's the one we already found. It could. Remember if you wrote out the equation, right? You can write out the equation that's given and try to do what? Factor. You can try to factor. Some of your gatekeeping factor. Okay, so you want to try to factor. Okay, so this is a quartic. So we just had mentioned in the previous one, right? We keep going till we get a quadratic, or in rare cases, we can factor. So this is the constant term. Then we have the coefficients of the x terms. So I have 1x to the fourth plus 2x squared plus 1. I'm going to set it equal to 0. There's no GCF, so I'm going to try to factor. Okay, so let's write it out. Okay, so what multiplies to x to the fourth? What times what? Yeah, x squared times x squared. Okay, and the only thing that is going to multiply to 1 is what? 1. 1 and 1, plus 1 plus 1. Okay, so yeah, we have the same two factors, but we're going to solve each of them. So you have x squared plus 1 equals 0, and here you have x squared plus 1 equals 0. So in both cases, you'll get x squared equals -1. So to get x by itself, I have to square root. And when I square root, I'm going to get x equals what? Not just I, but plus or minus I. Great. Okay, so notice that those happen twice. So we do have to include the multiplicity here, okay, which is why we take the time to do that. So you need 5 zeros. That's the degree. So the first 0, don't forget 2. And then there's a couple different ways you can write this. You can write I with a multiplicity of 2 and -I with a multiplicity of 2. Oops, sorry, sometimes I say with, but you can just say multiplicity. Okay, and then earlier I just had people asking, well, can we do the plus or minus? You can do the plus or minus if you say each has the multiplicity. So each with a multiplicity of 2. That would be okay. Okay, just something that indicates each one is going to count. Okay, so 1, 2, 3, 4, 5 total. Okay, so you do have these cases where you can factor to find all of the real zeros. Some of you might be checking for it. Some of you might forget to check for it as you're working. So we're going to show just a couple ways to do this last one. If you can factor to find all the real zeros, you have to make sure you do that completely. That means if there's a GCF, if there's a pattern, you have to find that pattern in order to get all of your zeros. Okay, and if you have 4 terms, then you have to factor using what technique? You have to group them together, right? Okay, so I'm going to give you a moment to factor that. And if you finish that pretty quickly, I'm going to ask you to investigate what happens on the graph. So remember, you can only use the factoring by grouping if these two are the same. And this we should recognize as a difference of 2 squares. This one might take us another moment to realize, oh, this is the difference of 2 squares as well. So this one is x plus 1, x minus 1. This one is x squared plus 2, x squared minus 2. Okay, so it's like you're setting it equal to 0 and you are finding the zeros by solving. So x squared plus 2 equals 0, x squared minus 2 equals 0. Okay, so for these, we're going to get -1 and 1. Okay, and if you were to do the steps that we normally do in your first step, that's what you would see on your graph is -1 and 1. Those would be your x-intercepts, so that is fine. Again, I think a lot of you are going to go straight there just based on the pattern. And then here, if you get a square root, what do you have to remember that you put with it? That plus or minus. And then if it's negative, the I comes out. Here it's a positive, so you still need the plus or minus. Okay, so this is degree 6, so you need 6 zeros. So plus or minus I root 2, plus or minus root 2, and then plus or minus 1. Okay, so you don't have any multiplicities. Okay, some of you might think it's easier to do the synthetic division. If you set up synthetic division, I also want to remind you about placeholders. So if there's no x to the 5th, there's a placeholder. Okay, if there's no x to the 3rd, there's a placeholder. And then just again, I want to warn you about being careful with putting numbers too close together. So if you do the synthetic division, this is what it would look like. You'd have 1, you'd add straight down, you'd get 0 and 0. So you would have to keep track of a lot of zeros here. Okay, and then if you have another 0 to use, when you multiply, you get 0, 0, 0, 0, -4, 4. Okay, so this would be your number, x, x squared, x cubed, x to the 4th. So if x to the 4th minus 4 equals 0, your setup would be similar to this. Again, you would have to factor. And you would take your square root. And then the 1 and the -1 would come from the synthetic division. Okay, so you would have your choice for one like part C, okay, of which method to do. All right, so like I said earlier, this is going to be your first assignment in quarter 2, and I'm going to give you the rest of the time to work on this.